The Lockheed Martin F-22 Raptor is an American single-seat twin-engine all-weather stealth tactical fighter aircraft developed for the United States Air Force (USAF). The result of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed as an air superiority fighter, but also has ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems, and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft was variously designated F-22 and F-A-22, before it formally entered service in December 2005 as the F-22A. Despite its protracted development and operational difficulties, USAF considers the F-22 a critical component of its tactical air power. The fighter's combination of stealth, aerodynamic performance, and mission systems enable unprecedented air combat capabilities. The USAF had originally planned to buy a total of 750 ATFs. In 2009, the program was cut to 187 operational aircraft due to high costs, a lack of clear air-to-air missions during production, a ban on exports, and development of the more versatile F-35, with the last F-22 delivered in 2012. In 1981, the U.S. Air Force identified a requirement for an Advanced Tactical Fighter (ATF) to replace the F-15 Eagle and F-16 Fighting Falcon. Codenamed Senior Sky, this air superiority fighter program was influenced by emerging worldwide threats, including new developments in Soviet air defense systems, and the proliferation of the Su-27 Flanker and MiG-29 Fulcrum class of fighter aircraft. It would take advantage of the new technologies in fighter design on the horizon, including composite materials, lightweight alloys, advanced flight control systems, more powerful propulsion systems, and most importantly, stealth technology. In 1983, the ATF Concept Development Team became the System Program Office (SPO) and managed the program at Wright-Patterson Air Force Base. The Demonstration and Validation Request for Proposals (RFP) was issued in September 1985, with requirements placing a strong emphasis on stealth and supercruise. Of the 7 bidding companies, Lockheed and Northrop were selected on 31 October 1986. Lockheed then teamed with Boeing and General Dynamics, while Northrop teamed with McDonnell Douglas, and the two contractor teams undertook a 50-month dem-val phase, culminating in the flight test of 2 technology demonstrator prototypes, the F-22 and the F-23, respectively. Concurrently, Pratt & Whitney and General Electric were awarded contracts to develop the YF-119 and YF-120 engines respectively, for the ATF engine competition. Demonstration and validation was focused on system engineering, technology development plans, and risk reduction over point aircraft designs. In fact, after the down select, the Lockheed team completely changed the airframe configuration in the summer of 1987, due to weight analysis during detailed design, with notable changes including the wing planform from swept trapezoidal to diamond-like, and a reduction in forebody planform area. Contractors made extensive use of analytical and empirical methods, including computational fluid dynamics, wind tunnel testing, and radar cross-section (RCS) calculations and pole testing. The Lockheed team would conduct nearly 18,000 hours of wind tunnel testing. Avionics development was marked by extensive testing and prototyping, and supported by ground and flying laboratories. During demonstration and validation, the SPO used the results of performance and cost trade studies conducted by contractor teams to adjust ATF requirements and delete ones that were significant weight and cost drivers, while having marginal value. The short takeoff and landing (STOL) requirement was relaxed to delete thrust reversers, saving substantial weight. As avionics was a major cost driver, side-looking radars were deleted, and the dedicated infrared search and track (IRST) system was downgraded from multicolor to single color, and then deleted as well. However, space and cooling provisions were retained to allow for the future addition of these components. The ejection seat requirement was downgraded from a fresh design to the existing McDonnell Douglas ACES II. Despite efforts by the contractor teams to rein in weight, the takeoff gross weight estimate was increased from 50,000 pounds to 60,000 pounds, resulting in engine thrust requirement increasing from 30,000 pound of force to 35,000 pound of force class. Each team produced 2 prototype air vehicles for demonstration and validation, one for each of the 2 engine options. The F-22 had its maiden flight on 29 September 1990, and in-flight tests achieved up to Mach 1.58 in supercruise. After the demonstration and validation flight test of the prototypes, on 23 April 1991, Secretary of the USAF Donald Rice announced the Lockheed team and Pratt & Whitney as the winners of the ATF and engine competitions. The F-23 design was considered stealthier and faster, while the F-22, with its thrust vectoring nozzles, was more maneuverable as well as less expensive and risky. The aviation press speculated that the Lockheed team's design was also more adaptable to the US Navy's Navalized Advanced Tactical Fighter, (NATF), but by fiscal year 1992, the Navy had abandoned NATF. As the program moved to full-scale development, or engineering and manufacturing development, (EMD), the production version had notable differences from the F-22, despite having a similar configuration. The wing's leading edge sweep angle was decreased from 48 degrees to 42 degrees, while the vertical stabilizers were shifted rearward and decreased in area by 20%. To improve pilot visibility, the canopy was moved forward 7 inches, and the engine intakes moved rearward 14 inches. The shapes of the wing and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. The production airframe was designed with a service life of 8,000 hours. Increasing weight during development caused slight reductions in range and maneuver performance. The F-22 cannot be exported under US federal law to protect its stealth technology and classified features. Customers for US fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22, but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to prepare a report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on US aerospace industry. Some Australian politicians and defense commentators proposed that Australia should attempt to purchase F-22s instead of the planned F-35s, citing the F-22's known capabilities and F-35's delays and developmental uncertainties. However, the Royal Australian Air Force (RAF) determined that the F-22 was unable to perform the F-35 strike and close air support roles. The Japanese government also showed interest in the F-22 for its replacement fighter program. The Japan Air Self-Defense Force (JASDF) would reportedly require fewer fighters for its mission if it obtained the F-22, thus reducing engineering and staffing costs. However, in 2009 it was reported that acquiring the F-22 would require increases to the Japanese government's defense budget, beyond the historical 1% of its GDP. With the end of F-22 production, Japan chose the F-35 in December 2011. Israel also expressed interest, but eventually chose the F-35 because of the F-22's price and unavailability. Throughout the 2000s, the need for F-22s was debated due to rising costs, insufficient multi-role versatility, and the lack of relevant adversaries for air combat missions. In 2006, Comptroller General of the United States David Walker found that the DoD has not demonstrated the need for more investment in the F-22, and further opposition to the program was expressed by Secretary of Defense Donald Rumsfeld, Deputy Secretary of Defense Gordon R. England, and Chairman of U.S. Senate Committee on Armed Services Senators John Warner and John McCain. The F-22 program lost influential supporters in 2008 after the forced resignations of Secretary of the Air Force Michael Wynne and the Chief of Staff of the Air Force General T. Michael Mosley. In November 2008, Secretary of Defense Robert Gates stated that the F-22 was not relevant in post-Cold War conflicts, such as irregular warfare operations in Iraq and Afghanistan, and in April 2009, under the new Obama administration, he called for ending production in fiscal year 2011, leaving the USAF with 187 production aircraft. The F-22 modernization and upgrades consist of software and hardware modifications, or tactical mandates, captured under increments as well as numbered software-only operational flight program, OFP, updates. The first aircraft with combat-capable Block 3.0 software flew in 2001. Increment 2, the first upgrade program, was implemented in 2005 for Block 20 aircraft onward, and enabled ground attack capability through the employment of Joint Direct Attack Munitions, JDAM. The improved NAPG-77 Pulse 1 radar was certified in March 2007, and airframes from production Lot 5 onward were fitted with this radar, which incorporates air-to-ground modes. Increment 3.1 and updates 3 and 4 for Block 30 aircraft onward provided improved ground attack capabilities through synthetic aperture radar mapping and radio emitter direction finding, electronic attack and small diameter bomb (SDB) integration. Testing began in 2009, and the first upgraded aircraft was delivered in 2011. To address oxygen deprivation issues, F-22s were fitted with an automatic backup oxygen system, ABOS, and modified life support systems started in 2012. The F-22 Raptor is a fifth-generation air superiority fighter that is considered fourth-generation in stealth aircraft technology by the USAF. It is the first operational aircraft to combine supercruise, supermaneuverability, stealth, and sensor fusion in a single weapons platform. The F-22 has clipped diamond-like delta wings, 4 empennage surfaces, and leading-edge root extensions running to the upper outboard corner of the carriage inlets. Flight control surfaces include leading-edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all moving horizontal tails, stabilators. For speed brake function, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. The aircraft has a refueling boom receptacle centered on its spine and retractable tricycle landing gear. The F-22's aerodynamics, relaxed stability, and powerful thrust vectoring engines give it excellent maneuverability and energy potential across its flight envelope. The airplane has excellent high alpha, angle of attack, characteristics, capable of flying at trimmed alpha of over 60 degrees, while maintaining roll control and performing maneuvers such as the Herbst maneuver, J-turn, and Pugachev's Cobra. The flight control system and full authority digital engine control, FADEC, make the aircraft highly departure resistant and controllable, thus giving the pilot carefree handling.